Hey guys, today's lesson focuses on radians. You've heard that word before in our trigonometry unit. We talked about how on your calculator you wanted to make sure your calculator was always in degrees, not radians. Radians is something that is comparable to degrees, and we're going to show you today how, and simply show you how to switch between the two. Write down your I can statement. That is it for the day. One objective, be able to take radians and write it in degrees, and the other way around. Now in your vocabulary section, you do want to draw this picture. We're going to define radians as simply the angle made when you take the length of a radius and you stretch it around the circle. Let's make it as simple as possible. I get that it may not make total sense still to you, but the idea is you want to relate how radians compare to the radius. So here's the deal. If you took a piece of string, that's the best way to think of it, and cut it the length of the radius of a circle, then if you stretch that string out, wrapping around the circle, that's how far it would go. And when that happens, then this angle formed right here is the measure of 1 radian. Now, that's the concept. That's not really what we're going to use this year. You'll learn more about that next year. This year, you need 2 conversion formulas. Here they are. Degrees, 1 degree, is equal to, or can be written as pi over 180 degrees. That will be one possible conversion formula you will use. The other one is if you are in radians, 1 radian equals, the cool thing about it is not a lot to memorize here. The flip version of that, 180 degrees over pi. Please write these 2 down. You will use one of these 2 all day long in your complete assignment. So the key will be learning which one to use when. Here's the hint before we even start. Pick the formula so that when you multiply by that fraction, you are going to wipe out the measurement that you don't want. So if you're in degrees, you want to wipe out the degrees so that you're left with radians. If you're in radians, you want to wipe out the radians, which means wiping out pi, so that you're left with degrees. Let's see how that works. Example 1, we are in degrees and it asks us to change those to radians. So let's take what we've got, 690 degrees. We've got to multiply it by one of those 2 fraction conversions. So again, you want to wipe out degrees. So if we're multiplying, and it's, you know you're going to use a fraction, let's make 690 look like a fraction. And you want to pick this one. I'll go ahead and pick it for you this time and try to show you why. Because we said the whole idea is you want to wipe out the degrees so that you're left with radians. Being left with radians means you're left with the pi symbol. So watch what's going to happen here. Think of the degree symbol as like a variable, and if you've got one on the top and one on the bottom, you just wiped it out. So that's how you know what you want to pick. You want to put the degree symbol on the bottom of these problems so that you wipe out the degrees. Now, there's a couple of things you can do. You can simplify first, which is what I typically suggest, but I'll show you the long way on this one because some I prefer to multiply straight across and deal with the bigger numbers, which I don't like, and then simplify at the end. So let's multiply straight across. 690 times pi is simply 690 pi. We will always leave the pi symbol. You never have to multiply by 3.14 today. That's just an extra step. On the bottom, 1 times 180 is 180. Now this is your answer, but it's not reduced. Your first job is to see if 180 actually divides into 690 evenly. If it does, you're done. In this case, it doesn't. So we do not write decimals with pi. So what we do is we think of pi as a variable, so it's just going to sit there. So let's work on reducing 690 over 180. I hope most of you know this trick. You can ditch the zeros. And that's like reducing by 10, sorry. And that leaves you with 69 pi over 18. And then you use what you know from elementary school. Try dividing by 2, 3, 4, 5. You can start with the lowest number if you want to. So I recognize both of these as being divisible by 3. I'm just going to write that out to the side. And if you divide 69 by 3, you'll have 23. Leave the pi symbol. If you divide 18 by 3, you have 6. There's your final answer. I'll show you in the next problem how you could do the simplifying first, like we could have lost the zeros over here instead, wiped them out right there. and done that multiplying and dealt with lower numbers to begin with. All right, let's go to number 2. 120 degrees. Multiply it by the one which will wipe out those degrees. Obviously, it's going to be the same version we chose in this first example. Use the pi over 180 degrees version. Put your 1 right there so you see it is multiplying. Let's see what's going on here. The degrees cancel. I'm going to do some other cross canceling or reducing first. I'm going to go ahead and ditch the zeros. And I'm also going to go ahead and say, hey, I've now got 12 and 18. 6 goes into both of those. 6 goes into 12 twice. 6 goes into 18 3 times. Now multiply straight across the top. I now have a 2 times pi on the top. And on the bottom, 1 times 3. 2/3 pi or 2 pi over 3. That's the final answer. Okay, let's go the other direction. Convert radian measures to degrees. If you say radians, you should be thinking pi symbol. So this is convert from the pi symbol version to the degree version. So what will wipe out the pi? Obviously, it's going to be the one we didn't just use in example 1. We want the one with pi on the bottom. So that's 180 degrees over pi. Again, I'm getting that from the 2 versions you wrote down in your vocabulary section. I'm going to do some cross canceling first. Pi and pi, gone. 20 over 9 doesn't reduce, but 9 and 18 have a common factor of 9 actually. 9 divides into 9. So what I'm doing is dividing by 9. Goes into itself once. 9 goes into 18. Use your calculator if you need to. 20 times. And now we're ready to multiply straight across the top. In case I didn't reduce it enough, I would see that in the end. On the top, I'm doing 20, the pi is gone, times 20. 400, and that degree symbol is there. And on the bottom, I'm doing 1 times nothing, because the pi is gone, so there's a ninja 1 there. 1 times 1, 1. The answer is 400 degrees. Number 4. 7 pi over 3. Let's change that to degrees. So again, use the version that will wipe out that pi symbol. So if there's a pi in the top, we want pi in the bottom so that it wipes out. So that's the one we go with. And I'm going to do some canceling to start with. Pi is gone. 3 won't go into 7, but 3 and 180 are both divisible by 3. So I'm going to divide by 3, cross canceling here. 3 goes into 3 once, 3 goes into 180 60 times, and now I'm ready to multiply straight across the top and straight across the bottom. 7 times 60 on the top, and the degree symbol is there. 1 times nothing, which means 1. 1 times 1 on the bottom, 420 degrees. Final answer. You don't always get whole numbers, but typically you should on most of the ones we'll do. 90 degrees, pretty warm. Okay, best news of the day for you. Do not mark through them, but we are not doing example 3 nor example 4 because those are actually pictures needed for the next lesson. We'll let you know in that video if you need to come back and do them. So please don't mark through the problem, but know that you're done for the day. So no example 3 and no example 4. Have a great day, guys. Get that assignment done on time.